Okay, guys, so we are going to start with the transition elements. Before starting this transition element, let me tell you about the D block elements. Okay, so D block elements. Uh, I'm going to draw a periodic table up here. This is the sketch of the periodic table. These are different group 1, 2, this is 13, 14, 15, 16, 17, and this is 18 or 0. Okay, so these two groups, they are called as the S block elements. Okay, from 13 to 18, these are called as the P block elements. And up here, these are called as the D block elements. And these, they are called as the F block elements. Why they are given the different blocks name? The reason is that when you fill the electrons, the last electron that enters in the s orbital, so then it would be s block element. Take the example of the sodium up here. So sodium has got the proton number 11. So if I'm going to write down its electronic configuration, 1s2, then 2s2, then you got 2p6, and then 3s1. Okay, so if you see, the last electron has entered in the s orbital. Okay, so that is why it is called as the s block element. If you take an example, let's suppose from the group 15, nitrogen. Nitrogen has got the proton number 7, so 1s2, 2s2, and 2p3. So the last electron that has entered in the p orbital, so that is why these are called as the p block element. So d block elements are those elements when you fill the electron in the orbitals, the last electron that would enter in the d orbital. Okay, so just write it during the filling of electrons if the last electron enters in the d orbital, then it is called a d block element. Okay. Now the second thing, my dear, uh, in our syllabus, the D block elements, they are going to start from the period 4. So this is the period 4. Okay. So these all elements, they are present in our syllabus. So period 4 D block elements, they are in our syllabus and they are going to start from the scandium and they are going to end at the zinc. Okay, so from scandium to zinc, you can open up the periodic table. After scandium, you got the titanium. Okay, after titanium, you got the vanadium. Okay, so all these elements, 10 elements are present up here. Now, what should you do, guys? Everybody, just listen. Scandium, हम लोगों ने इनकी we have to draw the electronic configuration of it. So scandium, it has got the proton number 21. Okay. So now what should you do? You can draw its electronic configuration in two ways. The first method is this is 1s2. Then you got 2s2. Then you got 2p. It got 3 orbitals in it. One electron up here and then pair it up. Then you got 3s, 2 electron. Then you got 3p. Okay, so you got one electron and then pair it up like that. So these electrons up till here, they are 18 electrons. Okay, so 18 electrons, they are also present in the argon. So at the place of 4 of this one, instead of writing whole of this one, what should you do? For scandium, you should write argon. So argon means 18 electron has come. And after 3p, you people got the 3d like that. But you people are not going to fill the D. Before filling every D subshell, you have to fill the S subshell of the next shell. Okay, so 18, 19, 20, 21. So this is the electronic configuration of the scandium. Okay, so you should draw the electronic configuration in that way. So what you are supposed to do now, take the titanium, let's suppose. So titanium is 22. So this is argon. You should write it up here. Make the 3d orbitals, 5 orbitals up here. And then 4s up here. Okay. So 2 electron up here. And then 1 electron up here. So this is 18, 19, 20, 21, 22. Okay, so you should make the electronic configuration of the 10 elements from scandium to zinc. You should open up the periodic table and see the elements and draw the electronic configuration in this way, because that electronic configuration that would be used in the next part of the chapter. Okay, so start doing it. Hurry up. Okay, guys. Now, whatever the electronic configuration you people had made, the two elements, they shows unusual electron configuration. The first element, that is the chromium, and the second element, that is the copper. It has got the proton number 24, and this one is having the proton number 29. Okay, 24. So 18, 20, 21, 22, 23, and 24. And for this one, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. Okay. Now, my dear students, these two elements, chromium and copper. Okay. Chromium and copper. This is their normal electronic configuration. But they do not show this electronic configuration. Why? Because if one electron is short in the 3d and it would become half filled. It would become half filled. And if one electron is short in the 3d and it becomes completely filled. Okay? Completely filled. So what would happen in that case? One of the electron from the 4s, that would be shifted up here. And one of the electron from the 4s would be shifted up here to make the 3d half filled or 3d completely filled. Why? Because there is a special stability associated with the half filled and completely filled D subshell. Did you get it? GG. Okay, so just write down this thing, that chromium and copper shows unusual electronic configuration as there is a special stability associated with half-filled and completely filled. D subshell. Okay. Now we are going to write down the details of each of them one by one. So first of all, my dear, the chromium. instead of having the normal electronic configuration. And what was its normal electronic configuration? The 3D, it got 4 electron and 4s got 2 electron. This is the normal electronic configuration. Okay, shows unusual electronic configuration. And what is the unusual electronic configuration? 3d5 and 4s1. And what is the reason behind it? Because there is a special stability associated with half-filled D subshell. Okay. And for the second thing, for the copper, you should write at the place of chromium, you should write copper. All the other thing that is same. Here you should write 3d9 and 4s2 shows unusual electronic configuration. At the place of this one, you should write 3d10 and 4s1 because there is a special stability associated with the half filled. At the place of half filled, you should write completely filled. All the other things you should write same. Okay, guys, so just start doing it. Okay, guys, we have started with a chapter transition element, but I have not discussed even a single thing with you about the transition element. We started discussing about the D block elements, make the electronic configuration, and then I told you that these two elements they show unusual electronic configuration. Now come towards our main point. What is the transition element? Definition of transition element. Okay. The first thing you should keep in mind that not all the D block elements they are transition. Okay. So this is the periodic table. So not all the elements present up here, these elements, these whole element, they are not transition. Okay, only those D block elements which can form two or more than two stable ions. Okay, the first thing. And second thing, they have partially filled D subshell. Partially filled D subshell means that the D subshell should contain at least one electron, but it never be complete, it never be empty. Okay, so that thing is called as the partially filled. So if any atom which can form two or more than two stable ions and have partially filled D subshell, so that element is called as the transition element. Okay, so just write down the definition. First of all, not all the D block elements are transition. Okay, this is the first thing. The second thing, only those D block elements which forms two or more than two stable ions and have partially filled D subshell is called transition element. Okay. So for transition elements, the two conditions that should be fulfilled. The first condition that it can form two or more than two stable ions, and the second condition it has partially filled D sub. Partially filled यानी कि three. Partially filled का मतलब कि D सब शेल में भाई चाहे एक इलेक्ट्रॉन क्यों ना हो होना चाहिए. ना तो वो बिल्कुल एम्प्टी हो और ना ही वो बिल्कुल कंप्लीटली फिल्ड. दिस मींस दैट. ओके. अब इस डेफिनेशन पे दो चीजें पूरा नहीं उतरती थी. वो दो चीजें जरा गौर से देख लें कि वो कौन कौन सी दो चीजें हैं जो इस पे पूरा नहीं उतरती. ठीक है. द फर्स्ट एलिमेंट दैट इज द स्कैंडियम. इसका प्रोटॉन नंबर 21 है. Here we got two electron and here we got one electron. The second element which does not fulfill this definition, that is the zinc. So zinc got 30 proton number. Okay. So 2 electron in the s subshell and 10 electrons up here. Scandium जो है it forms only +3 ion. तो जब ये +3 आयन बनाएगा तो इसके दो इलेक्ट्रॉन ये भी निकल गए, ये 1 इलेक्ट्रॉन भी निकल गया, तो इसका डी सबशेल क्या हो गया भाई? होल एम्प्टी हो गया. तो इसका मतलब ये और ये बना भी सिर्फ +3 रहा है. तो दिस इज नॉट द ट्रांजिशन एलिमेंट. जस्ट लाइक दैट जिंक ओनली शोज +2 ऑक्सीडेशन स्टेट. तो +2 में ये दो इलेक्ट्रॉन निकल गए. D subshell that is completely filled. So that is why this is also not a transition element. So scandium and zinc both are not transition. Okay, why? Because the scandium only shows +3 oxidation state and it has empty d orbital after the formation of ion. Whereas zinc shows +2 oxidation state and it has completely filled D subshell. Its D subshell is not partially filled. So that is why this is also not transition. Okay, guys. So scandium and zinc are not transition elements. Okay, the first one, scandium only have shows +3 oxidation state and its D subshell is empty. Okay. Zinc only shows +2 oxidation state and its D subshell is completely filled. बस. ओके जी. बस क्या मतलब कुछ बस ये इसका स्कैंडियम एंड जिंक दे आर नॉट ट्रांजिशन. ओके.